Now evaluate this integration of cos of square root of 5x minus 3 dx. So we can integrate this by substitution method. Let me put square root of 5x minus 3 equals t. So this is the substitution which I'm going to make, so that this integral will be simplified in terms of t. So first we have to take the differentials on both sides. We have to differentiate the square root of 5x minus 3 as well as the t. So when you take differentials of square root of 5x minus 3, we'll be getting 1 by 2 times of square root of 5x minus 3, and then we have to apply the chain rule to differentiate this inside part. Differentiation of 5x minus 3 is 5, and then we have to put this dx, and this side we will be having dt. Uh, Make sure that you know how to do this differentiation of square root of 5x minus 3. Suppose if we have a square root of x, this can be considered as x power 1 by 2. So when we apply the power rule to differentiate, we apply like this: 1 by 2, 1 by 2 minus 1, and this is equal to 1 by 2 x power 1 by 2 minus 1 is minus 1 by 2. So this is equal to 1 by 2 times of root x. So basically when you differentiate a square root function, you end up with 1 by 2 times of square root function. So that is why I have written like this. I consider this whole thing as a square root function. When you differentiate the square root function, you put 1 by 2 and then the square root function, which is square root of 5x minus 3. And then we have to apply the chain rule to differentiate the 5x minus 3, which gives us 5 times, and then we have to put dx, and this side we have dt. So we can now solve for dx. So let me solve for dx from this one. I just keep the dx on this side and transpose everything onto the other side. So here I have to multiply by square root of 5x minus 3, and then I have dt this side, and then I have this 5 by 2 on the left side. When I transpose to the right side, I will be getting 2 by 5. So I can put a line over here. So now I have this dx equal. This has to be in terms of t, because we are going to convert everything in terms of t over here. So we know that the square root of 5x minus 3 is t. So therefore this is equal to t dt. I put the number in front. So this becomes dx is basically 2 by 5 t dt, which means I can convert this given integral everything in terms of t as, I'm going to do it like here. So this is going to be cos of square root of 5x minus 3. I replace it with the t. So therefore this becomes cos of t, and dx I can replace it as 2 by 5 t dt. So let me replace it here, 2 by 5 t dt. And this can be written as, I take the 2 by 5, this is a constant, I can put it in front of the integral. So I rewrite this as 2 by 5 cos t times t dt. Now to integrate this, this is basically a product of two functions. That is t is an algebraic function, and cos t is a trigonometric function. So we are going to apply integration by parts method. Integration by parts method. So in this method, we have to follow one of the rule, that is ILATE rule, which stands for I stands for inverse function, L stands for logarithmic, A stands for algebraic, T stands for trigonometric, and E stands for exponential. So let's find out on the first function. Do we have inverse function? We don't have. Cos t and t. Cos t is trigonometric and t is algebraic. We don't have. Logarithmic, we don't have. Algebraic, yes, we have algebraic. So this can be considered as u. So this ILATE rule is basically used to choose the u. So I choose the u as t, and then rest of the components, that is cos t dt, this I can choose it as dv. which means I have two parts like this. I have u and as well as dv. Now this side I have to differentiate. So I differentiate like this, du equal to dt, and this side I have to integrate. So when I integrate dv, I get v, and then integration of cos t is sin t. So now we have all the terms we can apply in the formula. So let me first copy that. So far we have 2 by 5 cos t dt. So this is in the form of u dv, and this says the formula is uv minus integral of v du. So let's substitute the u and dv here. So I have 2 by 5. I take this 2 by 5, I input it here, and then integration of this is equal to, I have to apply the formula here. So I have to take uv first. We have u equal to t and v equal to sin t. So let me multiply both of them. So I get t times of sin t minus integral of v. V is sin t. So I replace v by sin t, and du, I replace du by dt. So let's simplify this. So I have 2 by 5 in front. This t sin t is already integrated, so we can put it like this. And minus of integral of sin t is minus cos t. And since we have integrated everything, we can put the constant of integration. This is actually not an integration symbol, it's just a bracket. So let's simplify this. So therefore this minus of minus cos t, this will become plus cos t. So I can replace this as cos of t. This is equal to plus cos t. Now we have to do the back substitution for t. We know that t is, when we started in the beginning, we substituted square root of 5x minus 3 as t. So we can replace the t as square root of 5x minus 3. So therefore this becomes 2 by 5 square root of 5x minus 3 multiplied by sine of square root of 5x minus 3. We can put a bracket, plus cos t, that is cos of square root of 5x minus 3 plus the constant of integration. Notice that this 2 by 5 is multiplied this with these two terms. So I can rewrite this as 2 by 5, and I can also put the 2 by 5 for the cos term component. So this is the final answer, which means option C is correct.